Okay, let's take a look at substitution. Now, to solve using substitution, I need to get one variable by itself. In this case, one variable already is by itself. Everywhere I see y, I can plug in 5x plus 1. So I have 4x plus something equals 10. Well, what's that something? 5x plus 1. So if I have this, I can say 4x plus 5x plus 1 equals 10, because there's nothing outside parentheses. That means they're still necessary. I have 9x plus 1 equals 10. So 9x equals, well, subtract 1, 9. So x equals 1. Well, that's kind of nice because that's about what we got when we did graphing method. The two methods ought to have the same answer if you've done them correctly. But that's only x. I need y. So y equals 5 times something plus 1. That something is, put a 1 in for x, and you get y equals 6. So there we go. We thought it was somewhere around 1, 5 or 1, 6, and it is indeed 1, 6. Now, if it wished to verify, you could plug them in and they should work. But that's one way to do it. Let's do the other way. In this case, let's get x by itself. Now, x is by itself and I can plug it in. The problem with this is I have all these nasty fractions now. And I need to add this cross. I need to get common denominators, so I make that a common denominator. Multiply both sides by 4. They go away, and y equals 1. I'm sorry, y equals 6. Once I know y equals 6, x equals 10/4 minus 6 over 4. And you can see why we don't use this method. When you're doing substitution, it's only a good method if it's easy to get one variable by itself. I would not do this. It's a mess. I would do this. Now, there is another way to do substitution here. In this case, I could get y by itself pretty easy by simply moving the 4x to the other side by subtracting 4x, subtracting 4x. And now everywhere I see y, I can say negative 4x plus 10. So instead of y, I put that equals. And in this case, I start solving. And again, once x equals 1, I can plug it in anywhere. Y equals negative 4 times 1 plus 10. Y equals 6. There we go. So that is substitution.